Hey, welcome everyone. Welcome to this new webinar. In today's webinar, we'll talk about computational design. And here next to me virtually, of course, is Bayo. Welcome, Bayo. How are you?
Hello, I'm well, and yourself?
Yeah, I'm doing well. I'm quite exciting that we have this webinar. We have been planning this since a while. And yeah, now it's the moment to do it.
Yes.
I'm quite excited because I know that we'll talk about computational design and parametric design, and that you have some great examples with Grasshopper, Dynamo, and you even made a web application. So yeah, I had a little peek view in your presentation, which is great. So I'm super excited. And maybe Bayo, you can tell me a bit about yourself and how you end up falling in love with computational design.
Yeah, of course. Thank you so much for having me. First of all, I'm very excited to be here. So I mean, I'm a practicing architect in Cape Town, and I got into computational design when I had to use it on a project, which I will be talking about in this presentation. I won't ruin the presentation by spoiling it yet. But yeah, I've used it for almost 5 years now, and I think it's a very good tool to be using. And yeah, we'll see in this presentation.
Yeah, great. So you're in Cape Town. I'm in the Netherlands. I'm wondering, you people at home or at the office, maybe you can drop us a comment and tell us from which of place of the world you're watching. Yeah, it will be great to know that. And in the meantime, Bayo, I will say the floor is all yours. So let's get started.
Awesome. I'll get started shortly. Great. Thank you everyone for joining in and watching this presentation. As I mentioned, my name is Bayo Windapo, and this presentation is titled Computational Design in AEC, Innovations and Applications. This is a shorter version of a presentation I gave in a workshop, computational design workshop, about a few weeks ago. So if you're interested in learning more about this, please feel free to reach out to me on LinkedIn, and I will be happy to add you to the next workshop. Yeah, just a little bit more about myself. I studied architecture here in Cape Town at the University of Cape Town, got my master's degree, worked as an architect at Wolf Architects here in Cape Town as well, got up to the position of an associate. I've lectured as an assistant lecturer at University of Cape Town, and I'm currently a lecturer at the School of Explorative Architecture. And I'm also part of a group of computational designers here in Cape Town as well, Computational Design SA. Feel free to take a look at our YouTube channel, Computational Design SA. And very recently, about 5 months ago, decided to branch off to start my own practice. It's called Onile. We provide AEC, the AEC industry tech services to small and medium firms, computational design, BIM, LiDAR, training. Yeah, and that's about it.
Hey, I'm Bayo.
Oh,
Sorry to interrupt, because I forgot like a very, very important part of it, and
yeah.
it is that I will be the host. So I will try to be the people that is at home of at the office watching this webinar online. So I will try
Yes.
to ask Bayo the questions that I think you may have. But even better, of course, if you ask those questions yourself. So if you ask those questions through the chat on LinkedIn or YouTube, I will have them in the screen, and I will put them here so that Bayo can answer them, and we will be answering those questions during the presentation and also at the end. So don't be shy and just ask whatever you want to do.
Awesome.
Bayo.
Okay. All right. Awesome. So what is computational design? Let's take a look at what that means, right? So there's a misconception that computational design is more about creating complex geometry, but it actually isn't, right? I remember when I first came into contact with it back in high school, there were a lot of, I said high school, university, there were a lot of lecturers who spoke against it because they didn't really like the kind of buildings that came out of it. For example, this building by Zaha Hadid Architects, the Haida Aliyev Center, which I don't mind, and when also this building called the O Tower by Big Architects. These are quite, I think they're quite beautiful, but there's a misconception that that's all you can do with computational design, but there's a lot more you can do with it. In this presentation, I'll try to show you all these uses and also talk through how you can get into it yourself. So this is a definition I came up with based on my experience. I'm just going to read it out. Computational design involves a thinking process where design problems are broken down into smaller solvable problems. Solutions are developed for these smaller problems and combined to form a cohesive solution or algorithm. So let's unpack that. Let's use this black box you see here as the problem. What do we do as designers? We will typically, through an analytical process, we'll break this problem down into smaller manageable problems. Then we usually involve there's usually involved some level of categorization, cataloging, and then we go on to tackle these problems, addressing them one after the other. And we've formed solutions to these problems, keeping in mind the overarching problem, making sure that these solutions work together to form a cohesive solution to our problem. And then we string these solutions together to form what we would call an algorithm. So just take a few seconds and think, have you ever done this kind of design process before? Have you gone through such an analytical process before? If you have, I would argue that you're already a computational designer. You just most likely need to add a few tools to your tool set, like Grasshopper or Dynamo. But you're already involved in this thinking process, which is about systematically analyzing problems to solve them. So let's take a closer look at computational thinking in the AEC industry. For instance, let's take this here as a corner site where a client has asked us to develop a mixed-use building, right? So that's our site. And what do we typically do? The first thing is probably to find out what the setback of that site is. What are the rules that govern that site? Is it a mixed-use site? What is the overall height allowed on this site? Then we'll go through a process of dividing that volume into a set of floor plates. And then we also divide it up based on the requirements from the client in terms of if the building needs public spaces, offices, and residential functions. If the mix is approved, then we go on to more structural design and more detailed design. And then we cover the building up with some sort of facade. So obviously design is not necessarily linear in this way. There's a lot of give and take when we design things, but I'm trying to show here that a lot of the work we do already involves a lot of systematic, rigorous processes. And because of that, it is algorithmic. I would argue it's algorithmic and it's attuned to computational processes, to computational design. Okay. There's a book called Computational Thinking in Computational Design Thinking, which I used for a recent elective with students at the School of Explorative Architecture here in Cape Town. And in the first essay, I'll encourage you to get this book. In the first essay, there are two concepts which the author, Archimedes, mentions, which are called computerization and computation. And that's how he describes the way the two primary ways designers in the AEC industry interact with the computer. So the first one, computerization, is when we already have an idea, an idea we've developed together as a team, as a designer, you've developed it, or design you've developed with your client. And you take that idea and you simply represent it as is in the computer. I'm not saying there's not a further development, but the idea is that that initial design development is one of taking something you already have and then throwing it into the computer, right? The other one is which is computation, is when you use the computer and algorithms and parameters to develop a range of design options. And as the designer, you use your design skill, to select the right option to fit your design goals. So this is an example here of a simple script. This is just a simple script I developed in Grasshopper. Something that changes the twist of a building, changes the scaling of the floor plates, changes the number of floors, changes the height. You can imagine doing something like that on Revit, for instance. Just this very simple task would take me, doing a few iterations of this would take me a day or two, right? But with using computational design tools like Grasshopper, this becomes more streamlined. So now let's...
And Bayo, can I ask a question? Because
Yes.
you basically defined like two ways of working. Not the first one is that you really think of the design, try to put that in the computer, model it for whatever you do. I'm a structural engineer, so I do structural models. Architects do other kind of modeling, and then you iterate to find a solution. And then you have like the opposite, where basically you create a lot of solutions and you choose the best one. And you show Grasshopper, which is like a parametric model. Not do you think that to which category does that belong? Is it still like the first one when you basically iterate, of will you categorize it as the second one?
I would categorize it as the second one, because the second one is about working with parameters, right? Yeah, so I would categorize it as the second one.
Yeah. And what I'm also wondering, for maybe the question is for the people that are watching us. So what's the way you work at the moment? Are you kind of creating those models yourself and iterating like more in the classical way, of have you already took some steps in towards computational design, of parametric design, of generative design, of one of those methods? So maybe you can drop us a comment and we can have a feeling about what you are doing there.
Awesome. So for me, it's in the past, it's been a mixed bag, really. So the project I'm going to show later on, there were some things we did very manually, but looking back, now that I have all these skills, I figured, because this building was a very simple 9-sided building, we could have modeled quite a lot of it parametrically. So there was one aspect of it which we did use a full computational process, which did streamline our work. And there's an app I've actually developed on your platform, which I'll also be talking about later, which I have been developing using these this computational thinking processes as well. Hello?
Yeah. Go ahead, please.
Okay. All right. So we've spoken now about what computational design is and the way we work in the AEC industry using these tools. So now, for me, these are the challenges I'm about to mention are the reasons that I really invest time and effort in learning this. And I think it should also be for AEC professionals, they should also be top of mind as well. Right. The first one is the built environment. According to this research that I found, done by the United Kingdom Infrastructure and Projects Authority, they've shown that the overall the overall AEC industry has only grown in productivity by just 10% over the past 2 decades. It lags behind the manufacturing and agricultural sectors, which have seen 70% and 40% growth, respectively. Right. The next one is the fact that a lot of people are now moving, and as we go forward in the next few decades, a lot of people are moving from rural areas into cities. This is putting a lot of pressure on our cities, meaning that we have to provide a lot of housing, a lot of infrastructure to meet the demand. There's a staggering statistic that says that by the year 2035, there will be about 3 billion people living in inadequate housing, essentially homeless or living in shanty towns. So you can see in this image on the screen, I mean, in 1950, about you can see there, in 1950, that's the amount of people that weren't living in cities. And now by 2015, you see the graph here that in the black areas, more than 50% are living in urban areas. Also, everyone knows this, our building industry, the construction industry releases about 40% of the world's carbon, right? And consumes about 36% of the world's energy. So I'm showing you here that there's low productivity, right? And there is high demand for housing. We have to produce things much faster, and we also have to do it sustainably. With computational tools, we can achieve these things, and I'm not saying it's a silver bullet, but this is one of the tools in our tool sets, in our tool sets that we can leverage to mitigate these issues. All right. Now we've spoken about some of the problems we're facing in the industry, but who do you have to be a computational designer? To be a computational designer, you still need to have the domain knowledge. If you're trying to automate something for the architecture industry, let's say you're trying to automate the design of apartment units or the design of housing, you still need to understand how these things work. So I would encourage you still to learn how to be a good architect for that domain you're trying to automate. So you still need that knowledge. You also have to be a good collaborator. Collaboration skills are quite key as a computational designer. Data-driven decision making. Computational design is really about using data to make data-driven design decisions. And then also very important is to have the programming and software skills. Dynamo, Grasshopper, learning how to program with C#, Python, also very important. So a computational designer is a nice mix of all these skills. Awesome. All right. Then now, what is visual programming? So a lot of the computational design tools out there, for instance, Dynamo and Grasshopper, are called visual programming tools, simply because they use these typically rectangular graphical objects called nodes. These nodes essentially abstract a lot of the programming that's involved. So for instance, this one is called point by coordinates, and in Grasshopper, this one is called construct point. They do exactly the same thing, but they abstract the textual programming behind them, which makes it easier for professionals in the AEC industry to get into programming, because obviously we're very visual people, and not a lot of people, let's be honest, want to be stuck with a lot of text. Okay, so this is an example of a visual program, and at the bottom, as you can see here, there's a textual program doing the exact same thing. And as you get more advanced in computational design, you'll find that you actually do need to start getting into the textual areas. But my advice is always to start small. So this is one I've built here in Python. I was just doing the exact same script you saw in the beginning, but this was all written fully in Python, doing the exact same thing. As you started building more more complex workflows, you certainly will have to get into this as well. Anand, are there any questions by any chance?
Not yet, but maybe there will. So again, a reminder for everyone that's watching us: if you have any questions, just post them, and we will put them online here and share them. But we have a lot of reactions of people, so we have people around the whole world watching us. So that's great. Yeah.
Awesome.
I have a personal question regarding what
Okay.
you explained. So what really makes sense to me is when you say that if you want to be if you want to automate a process, you still really need to understand that process. Not so if you want to be a computational
Exactly.
design, you also need to be a good architect or a good engineer. And that resonates with me a lot. My experience is the same. So I truly believe that the domain expert, to call it somehow, so the architect of the engineer should be like the one automating the processes. And I was wondering if you extrapolate that a bit in the sense that, okay, then you have that person that can do that, but as a company, are there some stuff that you need to have prepared also to be able to automate your processes? Like as a team, maybe?
As a team,
Mm-hmm.
you need to have some things prepared to automate your processes.
Yeah.
Like, for instance, I mean, if you have, I mean, the one way, I mean, I've been able to really automate a process was if everything is, the process is documented well enough. For instance, I was going to automate the parking layouts designed by an office that I used to work at, and also the design of units, because we were doing a lot of design of apartments, like probably double-story apartment units that had a lot of surface parking. So we had a lot of designs and a lot of documentation that I could then take and learn from to automate those processes. So, I mean, I don't know if that's answering your question. So
Yeah.
if
Yeah.
there's material to learn from to automate that process, and also you have to be good at researching to be able to automate something. You have to be willing to open a book or going on the internet to dive deep into that thing to be able to fully automate it in a way that will be useful to others, or else it just
Yeah.
falls flat. Yeah.
Yes. So it's really having like a certain degree of standardization, or at least
Yes.
really know the process you're using to design stuff, that you need to have clarity on that before you automate. Not that's kind of
Yes.
the conclusion I draw from what you say. Not.
Yes. Also, there's a lot of with the whole AI hype at the
Mm-hmm.
moment, a lot of people are trying to jump into using AI without having structured information. And you do need a lot of that kind of thing. I mean, just going back to what I was saying, you do need structured data to use AI at an organization. So it's a little funny to me with all this AI hype that, you know, these are a lot of companies that probably have not considered this before trying to jump into that. So you still need to standardize things before you leverage these tools successfully.
Yeah, and my experience, like on top of that, is that there's still so much to win with only like standardizing your process and automating that. That AI, of course, there's a lot of potential in AI, but you can still make such a big impact in your projects and the way you work without AI. There's so much to do still.
Exactly.
I have here a question or a comment. I will put it on the screen. I think you can read it too, not?
Let me
Do you see
see.
it on the screen?
Yes, okay, I can read it out.
Yeah.
Referring to the first couple of points you brought up about, I mean, everyone can see this. Do I need to read it?
Yeah. No, you can just answer the question, I think.
I'm behaving like a lecturer.
You are a lecturer.
I am, yeah. Okay, so I'm just reading it in my head. First couple of points. Yes. Yeah. Okay. So I was teaching computational design at C in Cape Town, and in Grasshopper, there are a lot of tools that you can use for these sort of analysis. I know Grasshopper has LCA tools. For instance, the one I saw was Bombix that allows you to do a lot of LCA lifecycle analysis calculations. But a lot of the data that's used for that is European, so it wouldn't really work here. We will have to gather the material data needed for it in South Africa. I think Adrian is from South Africa. Also, Ladybug tools have um, features for calculating wind speeds, energy usage, heat gain. I mean, I think there's acoustics, many other tools. So, for instance, with the one that does the wind speeds, you can easily see you can very accurately see using local wind data, local weather data, what the wind speed will be at a particular point in the building. But this is obviously a simulation, and you have to test it over and over to make sure it's right. But yeah, there are a lot of tools that we can leverage for that, for sure.
Yeah, and how I also interpreted the question was that maybe what's the real impact of computational design on reducing emissions, not? And of course, my meaning is that computational design definitely leads to better designs, and also outside like architecture, we have, for example, a case where people were optimizing pile foundations, and the amount of material you reduce, it's a lot. It can be 10-20%, and that is also like a big impact on the way we build and the impact we have on the environment, not?
Yes, for sure, for sure. And there are tools like generative design. For instance, a Grasshopper has Wallacey, where you can really optimize. You can really optimize a particular aspect of a design you're trying to that you're trying to optimize. So if your goal is to reduce the amount of carbon, for instance, you can build a script that tests all sorts of materials and tells you the overall carbon emissions that will be achieved if you apply this kind of timber instead of using steel. So it definitely, when applied correctly, can help you reduce carbon emissions if that's your particular goal. But if you want to learn more about generative design, please feel free to follow the Computational Design Essay YouTube channel. I have gone in depth about what it means and how it could be used using one example as well.
Okay, great.
Okay.
I think we can maybe continue with the nice examples you have. They're quite interesting.
Okay, let's go ahead. All right, Awesome. So we've had a chat through what computational design is, visual programming, and some of the issues in our industry. And now let's just take a look at a few examples of where different architects have applied it. Okay. So the first one here is the Shanghai Tower, designed by Gensler Architects. So they used computational design, Grasshopper in particular, to optimize the form of this building for the typhoon winds. I think Adrian would appreciate this one. So in Shanghai, there's quite a lot of the very strong typhoon winds that occur. So what they did was to, if you saw the script I actually did previously, it was actually this building. I was trying to mimic what they were doing there. I find that to be quite a nice way of learning as well. I just copy what other architects have done, and as a way of building up my own skills. So what they came up with was that the one that twisted at 55% and 120%, when they did CFD analysis, that's computational fluid dynamics, was the one that withstood those wind pressures the most. And then they also confirmed it using you can see how big that model is. They confirmed it using a wind tunnel, using quite a large scale model. The other way computational design was used in this building was to optimize the facade panels. So this building has, on the external facade, has about 28 8,000 glazed panels. That is a lot. So you can imagine if a building twists, that most of those panels will be different, right? But using computational design to optimize this, they came down to about 8 panels. 95% of that facade is made of only these 8. At the corners where you see here, where it's, it meets in a very funny angle, those had to be special. But still, the amount of material saving and the amount of cost reduction that was achieved through this process obviously is quite immense. So that is clearly a very good use of computational design.
Yeah, imagine the nightmare that it will be to have like 100 panel designs. Then these people installing these panels will be like crazy. Yeah, it's a really good application,
Right.
like to standardize this. Yeah, it's cool.
Yeah, right. Yeah, I can't imagine. I wouldn't want to be the one who builds that. Okay, so the other project where it was used was the Camp Adventure Tower by Effect Architects. I'm a fan of geometry like this. This is just super mathematical. And what I did is I actually modeled it myself in Grasshopper. So here's more photos of the project. So Effect is a Danish architecture firm. And what I did was to actually I just saw the image of that and I just decided, let me try this out myself. And yeah, so I modeled it up and I gave it all sorts of parameters for the ramp width, the number of structure it has, its height. Imagine having to do this in Revit, making different iterations of it, being able, trying to test the different aspects of it. Just from this one script, this one algorithm that was built, I could push and pull things apart till I come up with my final decision. Right? Every part of this building could be done in one script. And then because I've done this, I can then go on to do other analysis. For instance, I was trying out this plugin for Grasshopper, which is called Karamba, which is for structural analysis. This is an exaggeration of the displacement, but you can go on and test different materials like wood, aluminium, and see the overall displacement. As an architect, you can do this. You don't have to wait for a structural engineer before you start testing your designs, right? That is just very useful. Yeah. And for me, this was the project where I first came into contact with computational design. Like in practice, I'd seen it while I was at school, but we had a problem where there was a 3,000 square meter surface area of this temple. Its external surface had tiles of 9 different colors. And we were trying to figure out, I'll just let this video load. We were trying to figure out how to manufacture this thing, right? As you can see there, 9 different colors. We had to quantify each of those colors so we don't over purchase on the colors, or else that would be a waste of money. And we also had to produce fabrication drawings for this that explained clearly to the workers on site where to place what color. So I had an inkling in my head that Dynamo would work, and I put up my hand because I enjoy taking taking risks. And yeah, we tried it out and it worked. But let me explain the process, what we did. So we wanted the design to, in a way, mimic the traditional fabric of the Congo. I think about 3 tribes use this fabric. It's called the Kuba cloth. And what we were fascinated by at the time was the layering you can see. So that underneath there, you can see the brown layer, and on top there's another pattern. So we're trying to create a pattern like this on the building itself. So the process was to use Dynamo to get those curved surfaces of the building, flatten them. So that's a script that we used to flatten. So using the Dynamo Unfold package, we got the flattened surfaces. So we didn't have to do that for this because the dome was flat. is actually made of flat pieces. But for instance, the lower canopy you saw in the video had to be flattened. And then we gave these flattened surfaces to an artist who painted the pattern onto it. The artist is called Mayo Marx. Feel free to scan that QR code if you want to read more about it on the Wolf Architects website. So the artist is a famous South African artist, and she paints in these very thin lines, which are quite beautiful. And so we got this artwork from her, and the next step was to go back into Dynamo with those pieces and start using Dynamo to pick the colors at different points, and then throwing it onto the dome surface, for instance, as you can see here. Okay. Then from there, we were able to then produce these drawings, just by running the script, and it creates that for us, which we can then send over to the site for construction, right? So as you can see, all those tiles there, those little squares, all of them were tagged, and then they could be used to lay those tiles on the actual building. So it's a very fascinating process. And if you want to read more about the detail, about how it worked in detail, feel free to scan that QR code as well, and it will take you to a blog post I wrote on it. Yeah. And the last project
I have a question from someone that's watching, from Derek. He's asking basically, like, what are the challenges when you regarding adoption of computational design tools, and maybe if you have some lessons you want to share about how to do this successfully. And there's another person also asking, like, what's your experience like in teams? Is like, are people in the workflow enthusiastic about that? Are managers understanding this? Is there buying from like the higher management and the budget holders? What's your experience?
For personal experience, I'll be honest, people don't understand. It's so niche, in my view. I mean, at least where I am in South Africa. The office I was working at, no one knew about computational design. I was the first person to show it. So the process I went through to convince people of it was to educate them about it. But even after that, a lot of people are not interested in engaging with the Dynamo and Grasshopper wires. It's a little scary to a lot of people. So my advice to implement it is to find a way of simplifying how people use the script. Right. So one of the ways I'll talk about lastly. So for instance, we created almost 200 scripts that no one used, because they do not like to see all those little rectangles. It's just
the spaghetti monster, as they call it.
Yeah. People don't want to interact with it. So we got a lot more success when we use this tool called PyRevit. So with PyRevit, you can package your nodes in a Revit ribbon, and then they can run it from within Revit. So they don't have to mess with the spaghetti monster, right?
Yeah.
But it's still kind of hard to use, because running it in that way is still kind of slow. So my advice for anyone who wants to build those kind of scripts that help people automate drawings and all that sort of stuff is to get into Revit API programming, because that it works with C# and is much faster. But to get people to use in the office, you really have to get into learning how to explain things to people in a very simple way that gets their buy-in. Like, for instance, with the examples I'm showing you, be willing to give talks to people in your office that educates them over time. Change is very slow, but you have to be willing to just walk that walk and promote it.
Yeah, and maybe I also think, like, at least what I have experienced is that because someone asked, like, about people with budget, not like managers or other leaders, that sometimes we don't talk the same language. Not like as an architect or as a structural engineer, we have the tendency to talk very technically about computational design and what you can do. But sometimes we also need to make that more accessible for those decision makers and really talk about, okay, if I do this, I will maybe save, I don't know, 1,000 hours in a year.
Exactly.
I will be able to help clients much faster, and we will win more projects. So
Exactly.
talk a bit on the language that they talk about the things they care, and I think that helps a lot. And you also say it bio user friendly, no? So the spaghetti monster and those nodes can be daunting, and you made a web application which is quite user friendly. So I think that's maybe a good bridge to say it that way.
Yes, yes. Yeah, I'll get back into that, but yeah, something I didn't mention was in that last project, we thought all those drawings would take us about a year to do when we're doing it manually, because we already tried doing it manually, basically overlaying the JPEG on a grid and then picking the colors. Can you imagine how long that would have taken us? So we thought it would have taken us a year, but we cut that down to 2 months, having not known any Dynamo whatsoever. Over those 2 months, we researched it and then we applied it, right? So that was a saving of a lot of time, right? So the boss I used to work for also didn't know about computational design, but from that result, he could see the value in it. So the other thing is to be able to show what it can do and not just say what it can do, right? Be able to prove it. So that's if you can prove that it does have that sort of value, people will. I mean, there's no way they won't go for it because now it's saving them money, right? Time is money. Okay.
Did you have to go the full mile, or did you make like a small pilot to say somehow and show it to the managers and say, hey, look, I investigated this. I think there is potential. This is what I can do, and if I spend maybe 1 month more, I can do this completely. Of what was the process?
Luckily enough, that office was very experimental, so I didn't have those issues. So
Okay, that's great.
we spend a lot of time experimenting. So I spent probably a month researching it. I didn't have a fully developed thing yet, but I could still go along and finish it. So luckily I had that. There was that kind of environment of learning. We took risks, so I didn't have those issues. Yeah. Yeah. Okay, last one.
Great.
Cool. Right. So the last project I'm going to show you here is the Victor app that I built, which automates the layout of parking, right? So this is another way computational design can analyze things. So this is generative design. So I call it analysis because I think it helps you as a designer, engineer, architect to analyze the design space by producing a lot of design options for your particular goal. So I developed this parking algorithm on Dynamo. So what it does is you can draw any polygon outline as long as it has straight edges. It will lay out those parking spots in that polygon. And then you can feed that algorithm into Autodesk's generative design tool, which is called Refinery. But a lot of people don't know where it is. I think it's in the Manage tab, and you'll see generative design. So you can only use it if you have the AEC collection, typical. um, but basically, after you've developed a lot of options, you can pick the ones that fit your design goal. And then if you've developed the script in this way, you can then feed it back into Revit or Civil 3D or any other application that works with Dynamo. All right. So I saw a post by Anande, I think it was last year. Yeah, last year sometime. And I didn't know that Victor allowed us to develop apps with Dynamo. So for me, this was exciting because I was like, now I have this. So why not try and push it into a web app? Because this was an interest of mine. Right? So I was very impressed with how Victor made this process, simplified this process. So knowing Dynamo and Python, I was able to become a web developer quite quickly. So I took that same parking algorithm, did some Python code, and then fed it into this, essentially this web app, developed this web app. So what the web app does is any user could come onto the app, change a few parameters, draw the outline like you saw. So draw an outline of your site, draw a few paths where you want through routes. You can also add areas where you actually don't want parking to be in as well. So it's a tool. I see it as a little bit as a tool for urban design. And then you can export this layout as a JSON file and run it back and run that file in Revit to create a layout like this, right? You can make this as complex as you want it. Really, your imagination is the limit. You can build all sorts of apps on Victor. So if you want a free Victor account, so the nice thing about Victor is, well, you have the opportunity to have about 5 free public apps, but Anand could talk more about this than I can. And then the last one is the same thing, but I'm just trying to show you that, yeah, it can do as many an area as large as you want. So I think this one is about 29,000 square meters, right? So at the moment, you can see here, there's no topography. That's because I haven't integrated it, but you can really build whatever you want. And I did make a YouTube tutorial here showing you how to build an app of yours from start to finish. All you need to know is some Python and how to use Dynamo. But yeah, it's a 3-hour video, so it's quite long. But after you've watched this, you'll be able to build your very own Victor app.
And Bayo, do you have the link? Do you have the link to those to the app and the tutorial? So if people want to check this, can you paste it in the comments, maybe?
I'll post them in the comments. Yes, thanks.
Yeah, that would be great. Yeah, yeah.
Thanks.
It's a super nice app. So the app is you have a script built with Dynamo, huh? And then you use Victor and to connect that, and so Dynamo is running on background, and people that use the app doesn't need to have Dynamo on their laptop or their computer, not?
No. So you do not need Dynamo at all. It's like any other web app that you use. You're just running the app on your browser, Google Chrome, and the app communicates with the Dynamo app in the back end. You do not have to worry about that. You do not have to worry about the spaghetti, if that's your gripe. Yeah, makes it very simple. So I have posted a link here for, I see the link isn't coming in properly. Well, for South African architects who want to claim CPD points, I'm just going to post it again. Sorry about that. You can just fill the form over there. Okay, just copy and paste that link. And afterwards, I will paste another link for the Computational Design SA YouTube channel.
And Bayo, I believe this was the first Victor app you ever made, not? That's the thing you said.
Yes, it was.
And how much time it took you to create this app? And learning Victor at the same time, not? So you did both. Basically, you learned Victor and you created the app.
Yes, I'll say about a month. Yeah.
Yeah.
About a month. And this was while working. I was spending a lot of evenings, but this was while working full time as well. So about a month.
So you didn't spend a month full time. So you were working, and in the evenings you spent some time. That was like your hobby project, to say it somehow.
Yes.
Yeah.
Exactly.
Okay. Yeah. It's amazing. Yeah. It's a super nice app. Yeah. It's great.
Thank you.
Yeah, I don't know if people online have questions still. So please post them, because we are about to end the webinar. I will put a comment actually from Oana about her experience. So she says, that it's related to the topic about how to involve other people, not is to often we try to show very like complicated cases because they're impressive and they look nice, but her advice is to stay more close to the basic things and explain how you can save time and get better designs with maybe the standard cases so that they do day to day, which I think it's great advice. So thanks for sharing.
That's a very good advice.
Yeah, that's great.
Absolutely.
Well, there are no other questions online. So I want you to thank you a lot for sharing your experience with us. And of course, thanks everyone that's online that took the time to watch this webinar. The webinar will be on YouTube and LinkedIn. So if you want to share it with some friends or colleagues, we'll make sure that all the links that Valle posted are working. And if not, we will post them again. So the link to the app he made, also the tutorial. I don't know if the source code of the app is something that you're willing to share, but if that's the case, he will share it too. And if not, it will not appear. I don't know if that's an option or if it's very private code.
Yeah, it's proprietary. Yeah, so it's not.
Yeah. Okay.
No, I would have loved to, but yeah.
No, but that's understandable. That's okay. So someone is asking for the link.
I see there's a question there.
Someone asked us like, it's very interesting, but he is a bit overwhelmed about deciding which software to focus on. So I think that's a common question, not? So you have Rhino, Dynamo, Grasshopper, Python. If you have to choose a single one to start with, what will be your advice and why?
So, I mean, look, it really depends on your case, what kind of work you do. So Dynamo works very well if you're using a lot of the AEC collection, Autodesk AEC collection. So if you already have, if you're already working Revit, you're already working Civil 3D, and you're already paying for a lot of those that software stack, it obviously makes sense that you use that. Rhino is another cost. So why spend that money going for that? On the other end, Dynamo is not very good at doing a lot of environmental analysis. So the wind studies, the energy analysis, the other life cycle analysis. Because I think the reason it doesn't have these tools is probably because it's a little slow at the moment. So Ladybug, for instance, doesn't have their tools in Dynamo. So if you do a lot of environmental analysis, it might be worth your while investing in Rhino and Grasshopper, right? If you do a lot of complex geometry, Rhino works very well with that, with a lot of NURBS modeling. Yeah, so that's probably where you want to be. So Dynamo works very well, for instance, because I've used it with Revit. It works very well when you're trying to manipulate that data within Revit, right? So if you want to schedule things out of in a way that's quite unique, that's quite complex, you want to do a lot of data analysis with Revit, you want to pull, you want to grab elements from the Revit document to do certain things with them. I don't know what exactly, you can use Dynamo. So it really depends on what you're trying to achieve and what software you're already using. Yeah, I hope that helps.
Yeah, I think that's great advice. So I will share that. I'm less into the geometric part, so I can imagine as an architect you're more involved in that. I was trained as a structural engineer, also worked there several years. My favorite tool got Python at the end. So what my experience was is that I started with MATLAB at the university. Then I started working and they didn't have a MATLAB license. So I ended up using Excel like 99% of the world. Then I find the limitation of Excel quite quickly. So Excel is nice because you can start quickly, kind of everyone has it, but you find the limit quite quickly though, if you try to make more complex things. And then I made basically the mistake of learning VBA, which is the way of programming macros in Excel. It was a total waste of time, I will say. It's so complicated. And then I end up doing Python, and I really liked Python in that sense that you can, at least for more engineering stuff, and when you have to manipulate a lot of data, and maybe when you want to talk to other programs, so running using the APIs and that kind of stuff. I think Python is very, very powerful. So at least if you want to learn something, maybe you can skip the Excel VBA part and either say, okay, if you're very geometry heavy, then of course go for Grasshopper. And if you're more into data and analysis and calculations, maybe Python is a very good option. But it's true, it depends a bit on what you do for a living.
Exactly. Yeah. I mean, I started with Python. I can't recall why, but I think it's because someone told me in the past that it's the easiest language to learn. Yeah, that's why. And I started learning. And true, it is quite simple. But now I've moved on to C# because I'm building special tools for Dynamo. And Dynamo was built in C#, so that's the best way to make those plugins. Yeah. So yeah, if you want to learn programming language, maybe start with Python, like Anand said. I mean, I found it to be quite simple as well. Yeah.
Okay,
And someone asked
that's great.
for links. Sorry.
Yeah, so someone is asking for the links. So yeah, as promised, we will check because Vajo shared the links. He shared them from an account called Computational Design. If it's the case that those links were not posted on LinkedIn for any given reason, check it in a few minutes. We'll make sure that those links are there. Vajo, I don't know if you have the time to maybe paste it in a few minutes there so people can see them. But no worries. They will be there. Yeah. Okay, Vajo. Yeah, thanks a lot again for all your insights and sharing your experience. It's nice to have people from different sides of the industry to share their experience. I think that's the way to go. We need to get smarter and share what we know. And of course, thanks everyone at home. Yeah, for being with us. And yeah, see you again in the next webinar. Bye bye.
Thank you for having me. Cheers. Bye bye.
Bye bye.